Okay, I wanted to talk a little bit about labs. You are going to get confronted with some, what I would say are somewhat complex weather maps. I don't think any of you have ever paid much attention to them or observed them much. So they come on the news. Sometimes you'll see on the news a map showing a low pressure system moving through your area or whatever. But you're going to begin to get into right away here in the very first lab you're going to see is a surface weather map. So let's look at a small portion. I kind of zoomed it in some so you could look at it in the smallest detail I could find with a little bit more ease of looking, shall we say. All right. So what are you seeing here? The surface weather map is all surface observations plotted at exactly the same moment in time. So with that, we have a surface plot right here. You'll notice the circles. Circles are where the observation is taken. So in other words, somebody at this location walked out the door or automated equipment and took an observation at this moment in time. They also did it over here in Ohio. They did it here in West Virginia. They did it here in Georgia. They even had some instruments out over the water doing it. So the first thing that is done is every one of these observations are plotted on a weather map. So that's the first part. They're all plotted where they are. What they have on them is kind of important for how you analyze it. So we're going to start with pressure. Pressure is just the weight of the atmosphere above you. So the lower the pressure is, the low pressure system you have, bad weather. The higher the pressure is, better weather, usually high pressure. What we have here is low pressure developing over South Carolina. You'll notice an L. L typically is plotted on the weather map. Where in all of this mess do I find pressure? Well, look at this one right here. Probably Columbia, South Carolina. All right. Very upper right-hand corner, you see three numbers, 0, 6, 9. That is the surface pressure. Notice I said surface pressure. Every one of these are surface pressure at sea level. We're going to talk a lot more about that later, but let's just say that everybody is flat. There's no hills. All these observations are taken at the same elevation, sea level. There are three digits in the upper right-hand corner that are your surface pressure. Those three digits are only a part of it. Pressure is taken to the 10th of a millibar. So every one of those digits, 0, 6, 9, means there's a 0.9 there. However, standard atmosphere, most pressure is 1,000 millibars. So we would assume that this is going to have at least two other digits in front of it. Sometimes pressure goes below 1,000 millibars. It may be 999.9 millibars or 997 millibars. But if the number here is below 500, make it simple. You're going to put a 10 in front of it. So now you have five digits. This would be a 1006.9. That is your surface pressure. If I looked up here into North Carolina, 0092, put a 10 in front of it, it would be 1009.2 millibars. West Virginia at Beckley, 1008.5 millibars. So now we have the pressure. That's all we have. That's all I've talked about, pressure. It's the upper right. It's going to be three digits. So if I have that, I want to connect lines of equal pressure, isobars. So think about it. You're trying to connect the dots. So I know this pressure is 1,008.5 millibars. I want to draw a line where all the pressures are 1,008 millibars. So everything here along this line is 1,008 millibars. So here's 1,006.6 millibars. Well, guess what? That's lower than. So up here is 1,009.3 millibars. The idea would be, oh, I'm interpolating. Somewhere in this, between these two is 1,008 millibars. Probably closer to 1,009 millibars than 1,006.6 millibars. So somewhere closer to there. So somewhere up in here is 1,008. All I've done is connected a dot, a dot, a dot to get these. That is what you're going to do in your first assignment in your lab. Just connect the dots. You got to figure out where those dots are some. But I always would try to start where I have a pressure that equals kind of what I'm looking for. Now, pressure isobars, these lines of equal pressure. We draw them every 4 millibars, and yes, interestingly, they're all divisible by 4. So 1,008, I can divide 4 into that. 8 divided by 4 is equal to 2, so it's an even number. So we don't have 1,009 millibar map, because that wouldn't work out to a nice even number, would it? So 1,008, 1,012, 1,016, 1,020. See how the pressure went up in this direction? Down here, it's going down. Here's 1,008 millibars. And we know inside here it's actually lower than that. And they're estimating that the low pressure here is 1,006 millibars. So now you just analyzed the weather map. Wow. That is what you're looking at here. Yes, there are more things on here. There's a front. We have a warm front right here. We have a stationary front here. We have a cold front down here in Florida. But let's just start with that much. Now that you have that much down, you're a long way from looking at a weather map and saying, oh, gee, I can see some things in it. I can see the low here, or I can look up further up here and find some high pressure. And the world just kind of opened up. Here's 1030 high, millibar high pressure. So now you see what this, we're finding lows and highs. They tend to correspond to good weather or bad weather. Fronts. All fronts are these lines along here, and they're a shift in air mass. This is stationary. What you have here is a red semicircle to the one side and a diamond to the other. Here is a cold front that's moving, a diamond. On this side means it's moving towards the east. And if it's a cold front, it means the temperatures are going to drop when it goes by. The sun here in the southeast U.S. I showed you that low. Well, look at this warm front here. Now let's move on to the second thing you're going to notice. Every one of these circles has 2 numbers to the left of it. The upper number is the temperature. Everybody knows temperature, so simple enough. You want to know how cold it is outside. Well, why this is a warm front, look at this. Here is 59 degrees. Temperature over here is 37 degrees. Want to guess that there's a heck of a temperature contrast right there? If I drove right across this boundary, I would be getting much, much warmer when I went across it. That is what a warm front represents. The warm front's moving inland ahead of this low pressure system. So now we've talked about temperature. It's the upper left-hand one. The bottom left-hand one is dew point. It's a measure of moisture. How much moisture is in the air. The closer the temperature and the dew point are to each other, the more chance the air is saturated, 100% relative humidity. We're going to talk a lot more about that later. But if they're close to each other, it's very humid. If they're further apart, not so humid. So, yes, it's pouring down rain in this area right now, so it's quite humid. Looking also at the circle. That circle is colored all in. You can't see anything. It's just dark. Where the circle is colored in fully, it's cloudy. Where the circle is only partly colored in, it's not. Only that part of the sky, amount of the sky, is cloudy. You may have 3/4 of the circle colored in. Be partly cloudy, you may have half of it's colored in. 50% sky cover. You may have 25% or a quarter of it colored in. So you see, you can have different amounts of how much the circle is, representing how much of the sky over at your head is covered with clouds. Well, so now we've learned that we have pressure, we have temperature, dew point, and sky. So let's move on to wind. Wind is a barb. So meteorologists always take wind as where it's coming from. In other words, if I tell you you have a west wind and you're living in West Virginia or Ohio, that wind is generally must be coming from Indiana, Kentucky, Illinois, somewhere over that way. So it's come from your west to your east. And these barbs represent wind direction. Notice if you were to take a circle here and say, okay, due north is at the very top of that circle, due south is at the very bottom of that circle. Where this comes in at is the direction of the wind. Notice that this is just a little bit to the right of your circle top. So it's a northeast wind, or almost north-northeast. Maybe over here you'll see it's coming out of the southeast. It's in the southeastern quadrant. So you can get an idea of wind direction. And we want to know the wind speed. Notice this little one right here, just a little tiny barb. And then notice here the bigger barbs. 5 knots. 5 knots of wind is a tiny barb. Each one of these longer ones is 10 knots. So here, for example, I just add them up. And I get 10, 20, and 5 is 25 knots of wind, and it's coming out of the southeast. So now we have talked about clouds, wind, temperatures, pressure, and moisture. One final thing. We want to know what is going on. Is there some kind of weather, precipitation, or no precipitation? Fog, no fog. Haze, smoke. So notice here 2 dots. Notice down here 3 dots. Dots are rain. Stars are snow, for example. The more of them you are, the heavier the precip is. The less of them, the less precip. 2 dots is considered light rain. 3 dots is considered moderate rain. If I could find you 4 dots on here, it would be considered heavy rain. So that right there, always between temperature and dew point, is your precipitation. If there's nothing there, for example, right here, it's not precipitating there. So now we have got your station symbol talked about. That is the surface weather map. And I know that's probably confusing enough, but you're going to get in this week or so into the upper air. Meteorologists got to know what the upper air looks like. So all you're doing here on this little map is plotting a temperature and a dew point. All you've done. You have a pressure here so the pressure is the y-axis, temperature is the x-axis. So if I told you I want to know what 800 millibars is, and I give you a temperature here, that temperature right there, and the dew point, notice it's plotted exactly the same. So they are right at that point. There is your temperature and dew point. And you can see them going up, slowly getting colder with height, which they do. And right here, they begin to get warmer. This is where the stratosphere begins. So you've looked at the troposphere all the way up. Here's the tropopause. Here's the stratosphere. And you'll notice on this diagram, it also plots the wind. Notice how the winds get stronger as you go up, and here's the jet stream. So, hope you got a little bit out of this. I know this is confusing. I've taught this enough times. I know that. Please do not hesitate to ask me any questions about this.